Salam and good day. Today we will continue our lesson about the engineering economics decision making. Today we will discuss about the internal rate of return for presents. Okay, so we will use the internal rate of ratio here as a selection tool. Okay, we want to utilize the IR here as a selection tool of several project opportunity. Okay. For example, here the principle of this selection is based on uh, decision making should be based on several project comparisons. Okay. For example, here project M versus the project G. Okay. Or in easier case, either we want to select. Okay. Either you want to buy the Toyota Vios or we want to buy the Honda City. We need to check what is the initial cost to buy, what's the operating cost to maintain, and then after that any maintenance, okay, the fuel whatsoever there. Okay, we need to having this data set first and then analyze, and then we make a decisions, okay, by compare uh, these two options. All right, and then this selections principle also, we need to compare the cash flow, okay, between project, either A minus B or B minus A. So how we want to know exactly either A minus B or B minus A? It is based on most of the time the initial project analysis is a project with the least, okay, the least annual worth value which existed in the comparison. Okay, let's see the example. Let's see the first example of this IRR. Okay, we have project A and we also have project B. Okay, the first thing that we need to aware is, okay, what is the less annual worth for both project here. Okay, for example, in our case here, annual worth of B is 7,000, and we compare to annual worth of A project 8.2 thousand. So B is much lesser compared to A in terms of annual worth per annum usage of money. So the calculations should be uh, B minus A. Okay, the ones with the least annual worth should be uh, to compare first. Right? So in our case here, B minus A. So for the B minus A here, for the present worth of money here, 21. All right, minus the 15,000. All right, we will got 6,000 here. Okay, 6,000 here, and after that, we also have 7,000 minus 8.2 thousand. So we will got our value around negative 1.2 thousand. So once we got this negative value here, so previously our arrow is, okay, showing to the bottoms of our cash flow diagram, but now once we got this negative there, you need to realign back to become at the top of our cash flow diagram. So instead of showing to the bottom, okay, so this is not the case anymore because we have this negative value. Okay, once we got this negative value, then all of our per A here will become showing to the top there of our cash flow diagram. Alright, and then after that, for our future value here, Alright, B minus A, so 101, 105 minus the 0.75 here, you got 0.3 thousand. Alright, so this will become our new value of our F, new value of our A, new value of our P. Alright, and based on this calculation, we will accept, okay, project B, because it will save 1.2 thousand yearly for the operation expenditure. Let's see another example of this internal rate of return comparison. Okay, compare the difference between purchasing and operating a machine operated either by mechanical or automation. Okay, uh, we set our MARR, or minimum acceptable rate of return, at 10%. Okay, more than 10%, okay, we will select uh, the machine. Less than 10%, we will reject the machine. Okay, for the mechanical machine, there you require to purchase it at 8,000. Okay, for the automation, we need to purchase it at 13,000. The annual maintenance for the mechanical uh, system, okay, mechanical machine, is 3,500. For the automation is only 1,600. Okay, there will become no salvage value. Okay, but if you acquire automation system, you can salvage it after 5 years, okay, at 2,000. Let's see the solution. Okay, let's see the solution for this example. For the machine A, we purchase at 8,000 here. Alright, and then we need to maintain it for 3.5 thousand every year. Alright, for 10 years. And then for the machinery B, the automation system, the purchasing cost is 13,000. Alright, and then the annual maintenance is 1,006. Alright, 1,006. Because this machinery can only be used for 5 years, and we want to calculate for the NPV, or present worth. Alright, NPV and present worth, the years share must be the same. So for the automation system, we need to purchase it 2 times, at year 5th and also at year 10. At year 5th and also at the year 10 here. Alright, so the salvage will be happen 2 times, one at year 5th, second at year 10. Purchase will be happen at year 0, and after that at year 13th. Okay, once we are having this cash flow diagram, we need to find out which project is having the least per annum worth. So in our case here, B is 1.6, A is 3.5. So we know straightforward, B will be minus A, because the B per annum cost is only 1.6, lesser than 3.5. Okay, once we know this, okay, we will construct a new cash flow diagram, okay, based on B minus A. For example, here, uh, for the year 0 there, B minus A is, alright, 13. Okay, 13 minus 8,000. Okay, we got 5,000 here. Okay, and then after that, at year 5th there, uh 11,000 of purchasing. Alright, and then uh minus the 2,000 of salvage, we got total 11,000 here. Alright, because there is nothing happen. Alright, in 5th year. Okay, simple payment. Okay, at year 5th for the A there, straightforward, we got 11,000. And then after that, at year 10, what happened is we salvage another one, 2,000, right? 2,000 here, and then straightforward 2,000, no problem. All right, and then after that, for per annum B minus A, 1.6, okay, 1.6 minus the 3.5, okay, we will got 1.9, okay, negative 1.9 negative. We should having it here like this, okay, at the bottom of our cash flow diagram, but we convert it to become positive there, positive 1.9, so this arrow will become up thrust there, okay, to become towards our cash flow diagram. So here we see our per annum will be at the top of our cash flow diagram instead of at the bottom of our cash flow diagram, because we want to get this positive value of our per annum. Okay, once we got this understanding, we need to construct our equation, okay, for our cash flow diagram. So this year 0 here will become negative 5,000, okay, for our present worth today, what happened. And then after that, we also want to know what happened in our present worth today for our per annum. Alright, so this will become our A here, because we want to transfer it to know what happened in the present day at year 0 there. So we call this as finding P when we knew the A. Okay, multiple by 1.9 here. Alright, and then after that, we have this 11,000 as our future one. Okay, we want to convert it. We want to know what happened at the year 0 there. So we call this as finding P when you know the F1 here. So straightforward. Okay, at year 5th. And then after that, our survey value at year 10 there, this will become our F2. So we want to convert it. We want to know what happened at year 0. We call this as finding P when you know the F. Okay, straightforward. Insert in the our equation equal to 0. Okay, once we got this equation, the next step is we construct our table consists of interest rate, P per A, P per F at year 5th, P per F at year 10, and then after that, the collective value of our NPV. Okay, our boss says that he want at least 10%. Okay, at least 10% MRR. Okay, means that at least 10% profit, 10% of margin. So in this calculation, I just put more than 10%. Okay, one value here, I put it 11% of interest rates. So after that, I open the compound interest table for 11%. I found out under the column finding P when I knew the A at year 10, the value is 5.88 here. And then under the column finding P when I knew the F at year 5th and year 10, the value is 0.59, the value is 3.522. And then I put all this value inside here, and then the collective value for this NPV or present worth will become 0.365. Okay, it is positive. Okay, it is positive according to our schematic diagram there. It become positive there, but we want to know what happened approximate to 0, right? So if you put 11%, it will give you a positive value there. Alright, no problem. But we want to know what is the approximate to our 0 there. I just put another 12% there, and then we put the value from our compound interest table inside of our NPV equation. Okay, NPV equation, and then we will see that for each of the insertions of value there, my NPV will got, yeah, another positive there, 0.13. All right, wow, this is very good because our MRR is more than 10%, and now is more than 12%. Okay, more margin, more profit to everybody. So I put after that 13% here, opening the compound interest table for P over A, P over F at year 5th, P over F for year 10. Yeah, then after that we got the negative value. Okay, negative value here. All right, so straightforward, we know from this deal, okay, we can having more than 10% intent from our boss. Okay, and then we also know that the MR will be between 13 to 12% of profit margin. Okay, let's see the next step. All right, and then after that, from this continuation of the calculation, we see that we interpolate between 12%, okay, 12% and 13%. We want to know what happened to our I there. All right, we want to know what happened to our I. So yeah, we want to know at 0, okay, at 0 here. So what is our I? Okay, we interpolate it, and then I minus 12, okay, divide by 13 minus 12 equal to the value from our table here, and then we will see that we can gain 12%. Okay, 12.6%. All right, our MERR is only 10%. This is what intention by our boss. So we got more than 10%. Okay, 2.66 more percent. Okay, uh, then what our boss says. Okay, what our boss wants. So what we say here is we will accept B minus A proposal and buying machinery B. Okay, this 2.66% probably will become our, yeah, our bonus. Okay, bonus. All right.